Okay, good morning. I'm audible to you. Okay, today we are going to start the subject mass transfer. So basically, we are going to start the mass transfer operation. Anyone have idea about mass transfer? Mass transfer is a diffusion phenomena. Okay, transfer of mass from one point to other point due to concentration driving force. Okay, basically, what is the application of mass transfer? Actually, there are large number of unit operations are there which involves the change in compositions and change in composition in mixture or solution, है ना? So listen what I'm saying to you. There is a large number of unit operations of chemical engineering are there that are concerned with the change in compositions of solution and mixture through different methods and not necessarily involving chemical reaction, because if chemical reactions are there then obviously it will cause the change in composition. So if we are talking about those unit operations which does not involve chemical reactions and causes the change in composition, that called as mass transfer. Clear? So as far as mass transfer is concerned, means that due to transfer of species from there is always some change in concentration is there, change in composition is there. Clear? So what I told you, there are various mass transfer, there are various unit operations of a chemical engineering is there which concerned with the change in composition of solution and mixture, which does not involve any chemical reaction, because if chemical reaction is there in solution or in a mixture then obviously the composition will change, but I'm talking about those change in composition in the solution and mixture which does not involve any chemical reaction. So that is just because of mass transfer. So these operations which are talking about, which involves the change in compositions, or basically the change in composition is taking place in those types of solution and mixture because of separation of a substance into its component part. Means from those solutions or mixture, one of the components are going to separate due to separation of the components from the solution and mixture, that causes the that will cause the change in composition. Yes or no? So I talk about the two, one is solution, other is mixture. So once again listen, there are various mass transfer, there are various unit operations which involves in the chemical engineering applications, which involves change in compositions which does not involve chemical reaction, and that change in composition is brought in the mixture solution because of separation of the components into separation of components from the mixture or solution. When any components from the mixture or solution is going to separate, that causes the change in composition. Clear? For mixtures, such separations may be entirely mechanical. If we are talking about mixtures, such separations is entirely based on mechanical means. For example, if we have a slurry, and if the slurry is a mixture of liquid and what suspended solids, because in the slurries solids are suspended. For example, aqueous solution of CaCO3, calcium carbonate, then you can remove as the concentration, as the slurry is passed through filtration equipment, then obviously the concentration of slurry get retained, or you can say the amount of slurry get retained on the on the filter media, and that causes the reduction in the concentration of solute called as here calcium carbonate in the slurry. Yes or no? Similarly, in mechanical operation you might have studied the classification. What is classification? The classification is simply a separation of solid suspended in the liquid into different fractions based on their size, by screening or separation of particles of a ground solids according to their densities also. Yes or no? So this is also causes the change in composition. So as far as change in composition in the mixture is concerned, that is purely entirely based on mechanical means, mechanical processes, and that we already completed in mechanical operation. So if the separation of the components or constituent species is taking place from a mixture by the mechanical means, that we already dealt with in the mechanical operations. In mechanical operations, separation is there, but separation is from the mixture, and it is by the mechanical forces like centrifugal forces, gravitational forces, and all other like forces. For example, I told you, if you have a slurry and you allow in a sedimentation tank, you just keep in a tank and hold for sufficient time, then you will find the fraction, a different fraction of the uh, slurry based on their particle sizes. Similarly, based on difference in densities, we can also find the different fractions. Clear? Similarly, in the filtration, if slurry is allowed to enter through filtration equipment like plate and frame and other types of filtration equipment, then that also causes the change in concentration of the solids suspended in the slurries. So these are based on purely entirely, or you can say entirely based on mechanical means. On the other hand, if the operation involves change in composition of solution, if the operations of separation, it means if the separation is involved changes in composition of solution, they are known as mass transfer operation, and what we are going to concern here in this subject. So mass transfer operation, the operation which used to carry out the change in composition of solution, clear, not by mechanical means but by chemical means, based on difference in solubility, based on difference in boiling point, based in difference in volatility, like this what we are talking about here in this subject. Is this clear? So if any operation we are doing in a solution in order to carry out the change in compositions, and we must be careful in those solutions there is no chemical reaction, because if chemical reaction is there, then also it causes the change in composition. That's why we are going to remove that part of chemical reaction. So if there is solution is there, and if this solution, in this solution we are doing some operations in order to carry out the change in composition, that operation is called as a mass transfer operation. Clear? Is this clear? Pratisha. So basically mass transfer operation is a unit operation. Mass transfer operation is a unit operation. So again listen very carefully. If you are talking about the change in composition in solution or a mixture, or you can say there are various unit operations are there in the chemical engineering applications which involve the change in composition in solution or a mixture, which does not involve any chemical reaction. Means without chemical reaction, or you can say in the absence of chemical reaction, there is some mixture or solution is there which involve the change in composition. If you are talking about the change in composition in mixture, that is based on purely entirely based on the mechanical processes, and that we deal in the mechanical operation. In mechanical operation, just like also we are going to change the concentration of solution by removing the solute, by removing the suspended solids, by the mechanical forces like centrifugal forces, gravitational forces, and other forces. But if we are talking about the change in composition, if we are doing any operation, and solution to carry out the change in concentration without chemical reaction, that's called as mass transfer operation. It's very clear. And what is the importance of this mass transfer operation? What is the need of change in composition of solution? Because there are rarely any chemical process are there which does not require a preliminary purification of raw material or final separation of the products from the byproducts, and for these mass transfer operations are usually used. Means they are very rare. There are very rare any chemical process is there which does not require any preliminary purification of raw material. Because suppose if any mass transfer operation we are going to carry out, or you can say if any chemical process like a reactor, let's say you have a reactor is there. In a reactor, obviously we are feeding the raw material, and we are getting the product, you know. So raw material should be pure. So in order to make the pure from, you should remove the unwanted materials from the raw material, and that's called as purification. So actually what we're doing here in the raw material, that is liquid solution or gaseous solution, what is there, from those liquid or gaseous solution we should remove the unwanted material, unwanted components, and that is called as separation of liquid solution or gaseous solution in the raw material, and that's called as purification. So there are very rare chemical processes there which does not require any preliminary purification of raw material. And when the products is going to form, the products does not always in the pure form, it's also come with the byproduct. So we should also remove the byproduct from the main products, and it's also involved the mass transfer operation. So as far as upstream of the chemical process and downstream of any chemical process is concerned, in upstream there is purification is there, in downstream there is a separation of the byproduct from the main product is involving, and both is possible due to mass transfer operation. Is this clear? Clear? What are the okay now? There are different types of mass transfer operations are there. like some of the example of domestic example, a common example, other is some industrial example are there. As far as common example of mass transfer operation is concerned, uh, that's what a drying of cloths, or you can say if you are going to burn the agarbatti, then fragrance of the agarbatti molecules are moving from region of higher concentration to lower concentration. Dissolving of sugar cube in the water, है ना, dissolving of sugar cube in a hot coffee. If you are going to drop any copper sulfate into the water, that make the whole solution to be blue in color, है ना. These all example is of the domestic example or common example of the mass transfer operation. Now, as far as industry example of mass transfer is concerned, that's what removal of carbon dioxide from the polluted gas emerging from the chimneys, a flue gas from chimneys, that already we did in the process calculation. We have found the flue gases and we have measured the concentration of CO2 in the flue gases, है ना. So how can you measure, how can you remove that CO2, how can you reduce the concentration of CO2 coming from the flue gases? That via the mass transfer operation called as absorption, है ना. So there are different types of mass transfer operations are there depending upon how many types of phases are involved. As you know, there are basically three phases are there: gas, liquid and solids. So if you're talking about gas liquid operation of the mass transfer, in gas liquid the absorption is there, the stripping is there, the distillation is there. They all are the gas liquid operation, है ना. Humidification is there, dehumidification is there. They are all gas liquid. So that we will discuss in detail. But here I would like to discuss first. I just told you what is the importance of this mass transfer operation and what is actually the mass transfer. Mass transfer is simply the separation of a change in composition, or you can say any operation we are doing in solution to change the composition, that's only by a mass transfer operation. Okay. So as far as mass transfer operation is concerned, most of the mass transfer operation is used for separating the components of a solution, and that is going to be achieved by bringing the solution to be separated into contact with another insoluble phase. As far as industrial mass transfer operation is concerned, for example in absorption, so in absorption, stripping, distillation, extraction, these are common words and everyone is familiar with that. So suppose in absorption what we are doing, in absorption we have a gaseous mixture and a flue gases coming from the chimneys, that is called as gaseous mixture. And if you want to reduce the concentration of any specific gas, or you can say gas solution, you can say mixture means that's which are mixed. If you want to reduce the concentration of carbon dioxide or any species in a gaseous mixture, that is done by the absorption. So what we're doing in absorption, the gaseous mixture is allowed to be in contact with the liquid solution, and that should be insoluble, है ना. So that's why in the most of the mass transfer operations, the separation of the components from the solution results by bringing the solution to be separated into contact with the another insoluble phase. Clear? That called as solvent phase. Clear? And the rate at which component is going to transfer from the one phase to another phase, it means now two phases there, one is feed phase, other is solvent phase. Clear? One is feed phase means the solution from which the component has to be transferred, and when the separation of the component is from solution is taking place, then composition of the solution will get changes, and that's what we are talking about, mass transfer operation. So if any solution from which the component has to be removed, it allows to be in contact with the another insoluble phase, and when it is being in contact with the feed phase, then there is a transfer of a species from the one phase to another phase. And the rate of transfer of a species from one phase to another phase, the rate, or you can say the rate at which a component is transferred from the one phase to another phase depend upon what, the their rate coefficients, है ना? Because let's say in a solution we have different components are there, and every components have different rate of coefficients. So the rate of transfer of any species from the one phase to another phase, or rate at which any species or any components get transferred from the one phase to another phase, depends upon the rate coefficients, and also depend upon degree of departure from equilibrium. Yes or no? Because once the equilibrium is established, the transfer of the species from the one phase to another phase is continued till there is a departure from the equilibrium. Once the whole system reaches to the equilibrium, there is no mass transfer operation is there. Yes or no? Because equilibrium is the condition of stop, means nothing will happen. So when the system reaches to the equilibrium, then there is no transport of the species is there from one phase to the other phase. The transport of a species is only possible when there is a departure, when there is departure from the equilibrium condition is there. Yes or no? So depending upon the degree of departure from the equilibrium, there is a rate of transport of the species from one phase to the other phase. So in short, you can say the rate at which as the solution, which concentration at the solution from which the concentration of components has to be changed, is allowed to be in contact with the insoluble phase, that's called a solvent phase. Then there is a transport of the species or transport of the components will take place from the one phase to other phase, and the rate of transport, the rate at which the species get transported from one phase to other phase, that depend upon the rate coefficients, also called as transfer coefficients, and also depend upon the degree of departure of the system from equilibrium. As far as system is not in equilibrium, then only there is a transfer is there. Once system reaches to equilibrium, then transfer will be stopped. Is this clear? Same thing in the heat transfer, as you have seen, when the two bodies are allowed to in contact, and as long as there is a departure, as far as the system, the whole system is departed from the equilibrium, it means temperature of the two bodies are going to be different, then only the heat transfer is there. As the system as there is no departure from the equilibrium, it means the temperature of the bodies are equals, then there is no heat transfer is there. Similarly in the mass transfer, if you want to transfer the species from the one phase to other phase, and when you allow the two phases in the contact, there is always the transport of a species from one phase to other phase is there, but the rate of transport of a species from one phase to other phase, that depend upon the transfer coefficients, and also depend upon the degree of departure from the equilibrium. And what we have seen, actually the transfer coefficient of each of the components, or rate coefficient you can say, for various components in a given phase will be differ from each other to the greater extent under the condition where molecular diffusion will prevails. So what is molecular diffusion? I will discuss. So first of all, you must know कि let's say in a solution there is more than one components are there, and for every components there is different transfer coefficients are there. Different coefficients are there. Yes or no? Although the same departure is same driving force we are going to provide, but still the rate, just like I told you, when the two bodies are allowed to in contact and their temperature differences, their difference in temperature is there, when there is departure from equilibrium is there, but still the rate of heat transfer is different, because every material have different ability to conduct the heat, and that coefficient called as transfer coefficient in terms of thermal conductivity and all, है ना. Similarly, as far as transfer of species from the one phase to other phase is concerned, although the same degree of departure of equilibrium is there, but still the transfer coefficient of each component is different, because transfer coefficient of each component is going to be different. That's why rate of transport of each species, each components are different. Yes or no? So, and that coefficient is different for different components when there is a molecular diffusion is there. Clear? But still the difference in the transfer coefficient is not really very large. And under the condition of turbulence, where molecular diffusion is relatively unimportant, because I told you in the fluid mechanics and the heat transfer, when the turbulence is there, then molecular phenomena, I told you in the fluid mechanics is the momentum transfer is due to molecular phenomena when the flow is laminar. Similarly, in the heat transfer, the molecular diffusion or molecular heat transfer is by the conduction. But when I'm talking about turbulent flow, in turbulent flow, where the molecular diffusion or molecular phenomena is unimportant or not too much important, not important here, in those cases transfer coefficients of each components become much more nearly equal for all components. Clear? So in most of the problem, if we are separating the components on the behalf of their difference in transfer coefficients, if you are going to separate the components from one phase to other phase based on their difference in transfer coefficient, the degree of separation attainable in this manner is very small. Yes or no? And that's why we depend almost entirely upon difference in concentration which exists in equilibrium. That's why we depend almost entirely upon difference in concentration which exists in equilibrium, not upon difference in transfer coefficients. Clear? Clear? So a separation is taking place based on difference in concentration which exists at equilibrium. But still, nevertheless, the mass transfer coefficient or transfer coefficients are of great importance, because as they regulate the rate at which the equilibrium is approached. Yes or no? Ultimately, although the transfer coefficient are same for every species, and that's why we are not using the transfer coefficient, difference in transfer coefficient for the separation of components. But still the transfer coefficient is very important because that is the only which define the rate at which the equilibrium is approached, because once equilibrium is approached, there is no mass transfer is there. So in order to calculate the time required to reach the time required to complete the operation, the role of transfer coefficient is very important, because it simply calculates the rate at which the equilibrium is approached. They control the time required for separation, and if it controls the time, then obviously it also control the size and cost of the equipment being used for the separation. Is this clear? Any problem? So can you anyone elaborate? Can anyone summarize what I told you in short? First of all, we must know mass transfer operation is separation of the components from a solution. If separations are taking place using mechanical forces, that's called as mechanical operation. That you already did it by using the mechanical forces. In transfer operation, we are using the chemical means for the separation of the components from the solution. Using chemical means like difference in solubility, difference in volatility, and all. And a solution that is being separated is allowed to in contact with the another insoluble phase called as solvent phase. And when it is being contact, then components get transferred from one phase to other phase, and rate of transport, the rate of transport of the components from the one phase to other phase depend upon their transfer coefficient and also depend upon the degree of departure from the equilibrium. Once the equilibrium is established, then there is no further mass transfer, there is no further transfer of component is taking place from the one phase to other phase. So the magnitude of the transfer or rate of transport or magnitude of rate of transport will depend upon the magnitude of degree of departure and the magnitude of transfer coefficients. So if you want to separate the components from a liquid solution based on their difference in transfer coefficients, that is only be effective in the case of molecular diffusion, and in fact also it's not effective because difference in transfer coefficient is not too high even in the molecular diffusion. Transfer coefficient in terms of mass transfer coefficients. Clear? Now similarly, uh, if we're talking about turbulent flow, in turbulent flow where the molecular diffusion is not important, in those cases the transfer coefficient for each species are nearly going to be constant or equal for each species. Then if you want to separate, if you have a turbulent flow and you want to separate the components from one phase to other phase depending upon based on their difference in transfer coefficient, then separation is very limited, है ना? So that's why the transport of the species or rate of transport of species is entirely depend upon the concentration difference which exists at the equilibrium. Clear? Clear है? कोई doubt? If you have any doubt, please ask me. So I told you the two condition here, molecular diffusion and eddy diffusion. Two types of, what is a diffusion first? So before defining the mass transfer operation, I would like to define the molecular diffusion. Clear? Is this clear to everyone? Yes or no? So what is a molecular diffusion? Molecular diffusion means diffusion at the molecular level. And what is diffusion? Diffusion is the movement. है ना? So molecular diffusion is, I told you, molecular diffusion is nothing, it's concerned with the movement of individual molecules through a substance by virtue of their thermal energy. Because in the gaseous, in the liquids, or in the air, in the room, the molecules of the oxygen and nitrogens are moving, yes or no? In air, if you're talking about two components, air and oxygen and nitrogen, then molecules of the oxygen, molecules of nitrogen are moving, and they are moving just because of their kinetic energy, by virtue of their thermal energies are there. More thermal energy, more vigorously the components or molecules of the components will get moved in the mixture. So basically the diffusion, molecular diffusion is nothing, it's simply called as movement. So molecular diffusion is concerned with the movement of individual molecules through a substance by virtue of their thermal energy. Is this clear? Please write down. So what I am talking about here. So first I would like to define here what is molecular diffusion. Molecular diffusion. Still I have not told you any definition of mass transfer operation. I told you only what is the mass transfer, but definition of mass transfer I not define. Mass transfer operation, I told you any operation which involves the separation of components from a solution which does not involve any chemical reaction, that's called as mass transfer operation. So through mass transfer operation we can separate the components from the solutions that's for the mass transfer operation. But what is the mass transfer operation I have not defined still. So let us see here. As far as told you, I just also told you what is the importance of mass transfer operation. Now I am going to define here molecular diffusion here. So what is molecular diffusion first? Molecular diffusion is nothing, it is concerned with the movement of individual molecules through a substance, movement of individual molecules, movement is there, movement of individual molecules through a substance by virtue of their thermal energy. Clear? And from the kinetic theory of the gases we can visualize what occurs in the molecular diffusion. You might have heard about the Brownian motion in the chemistry. So same phenomena we can also elaborate with the concept of kinetic theory. The kinetic theory of the gases provides a method of visualization of what occurs at the diffusion. In this, through kinetic theory of the gases, a molecule is imagined. A molecule is imagined to travel in a straight line at a uniform velocity until it collides with the other molecule. Clear? Just you can see here in your room the air is there and there is a molecules of oxygen, molecules of nitrogen is there, and from the kinetic theory you can imagine ki the molecules of the species or travel in a straight line with a uniform velocity until it's collide with the other molecule. Once it get collide with other molecules, its velocity changes both in magnitude and direction. And the average distance the molecules travel between the collision is called as mean free path. What do you mean free path? The statistical average distance that is traveled by the molecules before its collision. It's called as mean free path. And the average velocity is dependent on temperature, because as temperature increases, average velocity increases. So what you can say, the molecules just travels a highly zigzag path, because once the molecules are going to be move in the straight line, they will collide with other molecules, and once they get collide, they will change the velocity both in velocity vector quantity. So it's whereupon the velocity gets changes in both magnitude as well as direction. So they may change its direction. Let's say this is any single molecule I'm talking about. So they will change its magnitude of the velocity and also direction. Again they will travel, again it get collide with other molecules, and once they get collide, they will change its magnitude and direction, and like this, है ना? So what happened here? The highly zigzag path is there. The molecules travel highly zigzag path, and the net distance in one direction. If let's say I'm talking about this movement, so if I'm talking about z direction here, so net movement of these particles in z direction is very small fraction of the actual movement. But actually the particles move from this plus this plus this it is, but net movement in any given direction is what? Only this much distance is there, yes or no? The net movement in z direction is only this, because molecules ultimately move from this point to this point here. So this is only net movement is there. So net movement or net distance in any one direction which it moves in a given time, that's called rate of diffusion. What is rate of diffusion? A rate of diffusion is nothing, the distance travel by the molecules in a given time, that's called rate. So rate of diffusion is only a small fraction, or you can say the net distance traveled by the molecule in a given direction is a small fraction of the length of its actual path, and for this reason the diffusion rate is very slow, or molecular diffusion is very slow process. Clear? And although we can expect to increase the rate of molecular diffusion by increasing the temperature and by decreasing the pressure. Increasing temperature will increase the kinetic energy of molecules, and decreasing the pressure will increase the mean free path. As mean free path get increases, pressure get decreases, mean free path get increases, and number of collision will get decreases. Clear? So increasing the temperature increases the molecular velocity, decreasing the pressure, that will reduce the number of collisions, and that's why the net movement in a given direction will get increases. That's what is called as molecular diffusion. Is this clear? Any problem? And if you provide sufficient time, then the phenomena of molecular diffusion ultimately leads to the completely uniform concentration of substance throughout the solution, which may initially have been non-uniform. For example, if you place a blue copper sulfate solution, if you drop a blue copper sulfate solution placed in a beaker of water, let's say this is a beaker of water is there, and if you are going to place a blue copper sulfate solution in this beaker. Then molecular diffusion, it means the molecules of the copper sulfate solution get diffuses, and diffusion is random motion of molecules by virtue of its thermal energy. So as the copper sulfate solution gently placed into the water placed in a beaker, then that ultimately means after a long time it causes the whole liquid solution as a blue in color. And after a long time the every solution is uniformly concentrated with the blue color, and no further change is going to take place because now system reached to the uniform concentration. Is this clear? This is what the molecular diffusion. कोई प्रॉब्लम? तो प्लीज राइट. By kinetic theory of gases, a molecule is imagined to travel in a straight line at uniform velocity until it collide with other molecule, whereupon its velocity changes both in magnitude and direction. The average distance the molecules travel travels between the collision is its mean free path lambda. ठीक है. And average velocity is dependent upon temperature, and this causes molecules travels in highly zigzag path. The molecules travel highly zigzag zigzag path, and the net distance in one direction the net distance in one direction which it moves net distance in one direction which it moves in given time in a given time is only small fraction is only a small fraction of the length of its actual path. क्लियर है या सुनो? And since net distance in one direction, which it means a net distance in one direction is in which it moves in a given time is only small fraction of its length, actual length, and that's why the molecular diffusion is very slow. I don't please complete line. That's why the molecular diffusion is very slow process. So why it is slow? Because as the molecules is imagined to travel in a straight line, that is going to be collide with other molecules, and upon collision it will change its magnitude and direction, and that's why it follow highly zigzag path, and that's why net movement in a given direction is only small fraction of the its actual movement. Okay, that's why the molecular diffusion is very slow process. Next point, although we can expect it to increase with decreasing pressure and increasing temperature, I don't molecular diffusion, a rate of molecular diffusion. So molecular diffusion, I told you, I had not told you anything about the mass transfer. I just told you the diffusion. Diffusion is simply the transport of the species by virtue of its thermal energy. You can have it in here. It is a concern with the movement of individual molecules through substance by virtue of thermal. That's called as molecular diffusion. And since molecular diffusion is slow process, that's why any mass transfer that is associated with the molecular diffusion will also be very slow process. So today here I will discuss only the molecular diffusion and how it can be related with the mass transfer, that I will discuss in the upcoming section. But how can you increase the molecular diffusion? By increasing the pressure and lowering the by increasing temperature and lowering the pressure. Increasing temperature will increase the molecular velocity and also kinetic energy. Please write. We can expect to increase the molecular diffusion with decreasing pressure. Decreasing pressure reduces the number of collisions. Second, increased temperature, which increases the molecular velocity, and ultimately it increases the rate of molecular diffusion. Now it is clear, beta. Now we must distinguish in the starting between molecular diffusion, which is a very slow process, I told you, and also more rapid mixing, which can be brought about by the mechanical stirring. and also the convective movement of the fluid. So what I'm saying to you, we must clear the difference in the starting between molecular diffusion, which is a slow process, and also the convective movement of the fluid. What is convective movement of the fluid? Anyone? One is called as molecular diffusion, other is convective movement of the fluid. यहाँ तो कोई डाउट हो, you can ask. So one I told you, molecular diffusion, which is very slow process. So that's why it's very important to have an information about the difference between molecular diffusion and more rapid mixing, which can be brought about by mechanical agitation, and also between the convective movement of the fluid. Is this clear? So just you can consider a tank is there, and in tank is filled with the pure water, and half is pure water and half is filled with the salt solution. So when you allow for sufficient time, then obviously the salt solution, how can you visualize the one example, one very nice example has been given in the tribal, and what they told you, what the example is there, if you can imagine, visualize a tank is 1.5 meter in diameter, its diameter is 1.5 meter, है ना, and onto which has been placed the salt solution to a depth of 0.75 meter. So here of 0.75 meter the salt solution is there, and above this we are going to place the water, pure water of next 0.75 meter. It's pure water. If you are going to place in tank gently without any disturbance, huh? So if the contents of the tanks are left completely undisturbed, if the whole system is made totally undisturbed, then the salt will completely permeate the liquid and ultimately coming everywhere to one half of its concentration in vaginal brine. So one half means what? So salt will get permeate because concentration of the salt, as we just in natural process is there, because you know molecules are moving randomly, and that's called as diffusion. So due to molecular diffusion, the molecules of the water and molecules of the salt is going to move here and there, and if the contents of the tanks are left completely undisturbed, then salt by molecular diffusion will completely permeate the liquid and ultimately coming everywhere to one half of its concentration in the vaginal brine. one half, because whatever concentration in that become half, because obviously the volume become twice. As the volume become twice, then concentration become half. Yes or no? Because whatever salt is there, let's say 0.75 meter and area, it means some volume is there, and equal volume of water we have placed over this pure water gently without any disturbance. Then obviously what happened, due to molecular diffusion or due to transport of molecules called molecular diffusion, the concentration of the salt become half in half of its original solution. Original solution में whatever concentration it's become half, because what is concentration, mole per unit mass or volume, sorry, mass per unit volume. Then volume become twice, mass is same, but due to transfer, what happened, now we got the solution of 1.5 meter here, diameter is 1.5 meter, and this becomes simply a, again liquid solution is there, but in this liquid solution the concentration is half of its original. Concentration of salt become half, yes or no, of its original solution. It's very common because volume become twice. But question is how much time it will take to reach the uniform concentration throughout. And what the table has been written in their example, and they have told you it may read about 99 years, about 99 years, sorry 10 years, sorry it's take about 10 years in order to reach the 99% of its final value after sorry, yes, 28 10 year, they give you it will take 10 year for the salt concentration at the top of the surface by 87.5% of its final value. Means whatever the concentration, let's say I told you uniform concentration is there, it become half. To become half throughout, it will take 10 year. It means that's just through example you can imagine how much slow is there. Yes or no? It means to reach the purely uniform concentration, it may take 28 years. On the other hand, if you are going to place an agitator in the same that rotate with the 22 rpm, and that will make uniform concentration in only 60 seconds. Can you imagine how much fast is if you are going to use a stirrer? So due to mechanical stirring, what happened? When we are going to place mechanical stirring, that makes the process very fast. But without any stirring, that process was very slow, and that's called as molecular diffusion. So what is the mechanical agitation does? The mechanical agitation has produced a rapid movement of relatively large chunks or eddies of the fluid, and eddies are nothing that is large chunk of liquid molecules is called as eddies, that I told you also in the fluid mechanics and heat transfer. So when we are going to use the mechanical agitation to do stirrer, that creates the rapid movement of a relatively large chunk of liquid that are called as eddies, and that create turbulency, and that eddies carries the salt with them, and they make uniform concentration throughout as early as possible, and it will take only 60 seconds. And this method of solute transfer is known as eddy or turbulent diffusion. So one we have told you molecular diffusion, and second I told you is the eddy diffusion. Two examples we have seen of the diffusion. Clear? So two types of mass transfer we have seen, And what is mass transfer? When the diffusion of the species are taking place from the region of higher concentration to lower concentration, that's called as mass transfer. Clear beta? So first I told you the molecular diffusion, and based on molecular diffusion the two types of mass transfer is there. One is called as molecular mass transfer, other is called as convective mass transfer. So first of all listen what I told you. One I told you molecular diffusion, and other is called as eddy or turbulent diffusion. So molecular diffusion, nothing, it's concerned with the random, or you can say it's concerned with the movement of individual molecules through a substance by virtue of its thermal energy. And if these molecules, if this random motion, if this molecular diffusions are taking place in presence of concentration gradient, if I allow the gradient in concentration, that's called as mass transfer. Is this clear? Well, you can say in simple, when the random motion of molecules are taking place in presence of concentration gradient, that's called as molecular mass transfer. Clear? A simple mass transfer is there. The mass transfer is transport of species from a region of when the transport of species are taking place. Transport is what? Diffusion. So you can say molecular diffusion in presence of concentration gradient is called as mass transfer. So mass transfer is of two types. One is called as molecular mass transfer, other is called as convective mass transfer. The molecular mass transfer, which are primarily due to molecular diffusion. Convective mass transfer, which are primarily due to eddy or turbulent diffusion. Clear? So example, through example, is everything is clear, yes or no? Tell me fast. So molecular diffusion is the mechanism of mass transfer in, listen, molecular diffusion is the mechanism of mass transfer in stagnant fluid or fluids which are moving only in laminar flow. So in laminar flow the mechanism of mass transfer is what? Or in stagnant fluid the mechanism of mass transfer through molecular diffusion. Just like I told you, when the fluid is stagnant, the mechanism of heat transfer is by purely conduction. Similarly, if we are talking about the stagnant fluid medium is there, in a stagnant fluid medium, any transport of the species from the region of high concentration to low concentration is due to molecular diffusion. The mechanism is molecular diffusion. And even also in the laminar flow, listen. So molecular diffusion prevails in stagnant fluid medium and also in laminar flow. Be careful. So molecular diffusion is the mechanism of mass transfer in a stagnant fluid medium or in the fluid which are moving only in laminar flow. But still the molecular diffusion also present in the highly developed turbulent flow, because I told you in highly developed turbulent flow the additional mechanism will come into picture, that's called as what? Eddy mechanism. Because eddy mechanism cannot be alone. I told you, just like in the fluid mechanics, I told you the two additional two mechanism is there for the momentum transport when I'm talking about turbulent flow. In laminar flow, the mechanism of transport of momentum is what by molecular means, that's given by Newton's law of viscosity. But in turbulent flow, the mechanism of transport of momentum is by the two mechanisms. One is molecular transport, other is called as eddy transport, and then combinedly will make the total rate of transport. And that's why total stress in the turbulent flow is laminar stress plus turbulent stress, if you recall. Yes or no? So although the mechanism of transport of species in external fluid medium is only by molecular diffusion, but this, and also in laminar flow medium. But in turbulent flow, still this mechanism is present. Although its magnitude is small, its contribution is very small as compared to the turbulent contribution, but it will be present. Clear, beta? So first, right, I told you just it is a molecular diffusion. Now the next is called as what is mass transfer. Please write, the mass transfer is the molecular diffusion in presence of concentration gradient is called as mass transfer. Clear? Or you can say not molecular only, you should say diffusion. It is a diffusion. So what is mass transfer operation? Now I am going to define mass transfer operation. It is a transport of species or component through medium having concentration gradient is called as mass transfer operation. So you can say also diffusion of species. Transport is nothing as diffusion, and diffusion is two types. One is molecular diffusion, other is called as eddy diffusion. Clear? So that's why I told you in the commonly it is transport of a species through a medium having concentration gradient. That's called as mass transfer operation. कोई problem? Types of mass transfer. Depending upon mechanism of transport, depending on mechanism of transport, there are two types of mass transfer. One is molecular mass transfer, and second is convective mass transfer. In molecular mass transfer mechanism, molecular mass transfer mechanism is molecular diffusion. You can write about this point. Mechanism is molecular diffusion. It prevails in stagnant fluid medium and also in fluid which are moving only in laminar flow, which are moving only in laminar flow. Clear, beta? This is what the molecular mass transfer. In convective mass transfer, the mechanism is eddy diffusion. mechanism is eddy diffusion or turbulent diffusion. एडी और टर्बुलेंट डिफ्यूजन, ठीक है। Clear? And obviously molecular mass transfer is very slow because its mechanism is molecular diffusion, while convective mass transfer is very fast because its mechanism is eddy transport or turbulent diffusion. Is this clear? Any problem up to this point? I defined what is the diffusion, then I defined what is the mass transfer operation. So if we have a two-phase system which is not at equilibrium, listen, two-phase system is there which is not at equilibrium, such as layer of ammonia and air. Listen, very important is there. Two-phase system means, let's say we have a layer of air ammonia mixture, air plus ammonia, sorry, it's water, and here air plus ammonia mixture is there. Two-phase mixture, one is gas phase, other is liquid phase. It's gas, it's liquid. These two phases are not in equilibrium initially. Clear, beta? Because I told you the mass transfer operation is the operation which used to separate the components by allowing the solution that to be separated with the insoluble phase, like a solvent phase. So here, if you want to change the concentration composition of the ammonia from the gas phase, then what we should do, we should allow the ammonia gas phase to be in the insoluble liquid phase. That's what is water. Clear, beta? Reason is clear, question is clear. I told you now what is the mass transfer operation. It's separation of components, separation of, you can say it's a change in compositions we may carry out by the mass transfer operation from a solution. So we have a gas solution is there, air ammonia, and if you want to change the composition of ammonia, then what we should do, we should allow the gas mixture to be in contact with the insoluble solvent, and that's called as a liquid solution, or water is there. And the rate of transport will depend upon, I told you, rate of transport, rate at which the species get transferred from one phase to other phase, gas phase to liquid phase, that depend on the transport coefficient or rate coefficient, and also on the degree of departure from equilibrium. Yes or no? Once the equilibrium will establish, no further transport is possible. The same condition is there. We allow the gas mixture, gas solution to be in contact with the liquid, insoluble liquid, and they are initially not in equilibrium. When it is allowed in contact, then what happens? There is a spontaneous alteration through the molecular diffusion occurs, because as they allow in contact, some of the ammonia molecules, some of the water molecules can start diffusing. That is a natural process. Diffusion means what? Transport. And if I told you, when the transport of the species is allowed to be in the with concentration gradient, that causes the mass transfer. So listen, so as they allow in contact, there is a spontaneous alteration is there, and that will happen through the molecular diffusion. And after some time, the whole system will reach to the equilibrium condition. And once the system will reach to the equilibrium condition, there is no further alteration in the concentration is there. There is no further alteration is there. There is no further change in the concentration. Concentration, or you can say alteration or change in the concentration of the ammonia in the gas phase and liquid phase will continue till system is not in equilibrium. Once system will reach to the equilibrium, no further alteration is there. And at the end of the operation, when the system reach to the equilibrium, what happen? Concentration of any constituents, either air or ammonia, is same throughout a phase. Same throughout a phase means it is not to be equal in all phases, but it is going to be uniform in the air. Whatever concentration of ammonia, it is same throughout the gas phase. Whatever concentration of ammonia in the liquid here, that will be uniform throughout the liquid. So what I'm saying to you, ammonia concentration will be uniform throughout the liquid and uniform at different value throughout the gas. Clear? And there is no further change in concentration is there because system reached to the equilibrium. Clear, beta? So although listens, let's say I'm here, it's y, it's x. Y is the mole fraction or composition of ammonia in the gas phase. X is the composition of ammonia in the liquid phase. And this composition of ammonia in gas and this composition of ammonia in the liquid is not going to be further get altered because system reaches to equilibrium, and that's called as equilibrium composition of ammonia in the gas and liquid. This is called as equilibrium composition of ammonia in gas and liquid. Why equilibrium? Because they are not going to further change, because this is the composition at the condition of equilibrium. It means if this composition, let's say y is 0.3 and x is 0.2, I told you these are not necessary to be equal, they are different. Means concentration of ammonia in the gas phase is uniform, concentration of ammonia in the liquid phase is uniform, but they are different in values, at different values. Here it's 0.2, here it's 0.3. What it means here? It means if you are going to allow this concentration of ammonia in gas phase and this concentration of ammonia in the liquid phase to be in contact at the given set of temperature and pressure, there is no mass transfer is there. Why? Because this is the condition of equilibrium at the given set of temperature and pressure. Clear, beta? For the mass to be transferred, there is always a departure from equilibrium. This concentration ammonia means 30% ammonia. It means, let's say for example, at any set of temperature and pressure, at a given set of temperature T and P, if 30% of ammonia in the gas phase and 20% ammonia in the liquid phase is in equilibrium to each other, that make the system equilibrium, or you can say these are the compositions at the equilibrium condition, then it means if we are allowing one gas phase, one air ammonia mixture having 30% ammonia, and one liquid solution, water solution, aqueous solution having 20% of ammonia in that, in contact at this temperature and pressure, there is no mass transfer. Why? Why there is no mass transfer? Why will there be no any mass transfer? If at this temperature, this pressure, this concentration of ammonia and this concentration of ammonia in liquid phase is allowed in contact. Yes. What about other people? Now it means, but at the same time, although the concentration difference is there among the phases, but still there is no mass transfer is there because system has been reached to equilibrium. It means from this discussion it's now clear that true driving force for the mass transfer between the phases, between multiple phases, is not the concentration difference. Because if I told you even the concentration difference is going to be exist, 30% here 20%, even the concentration difference is there between the two phases, but still there is no mass transfer is there because system reached to equilibrium. It means at the same time, if you are going to check for chemical potential or activity, then chemical potential at the condition of equilibrium for this concentration ammonia and for this concentration ammonia in the liquid phase is found to be equal. Are you getting a point? Although there is a difference in concentration is there in two phases, but still there is no mass transfer because system reached to the equilibrium. It means the true driving force for the mass transfer between the phases is not the concentration difference. Clear? Then true driving force will be something different, and that's what is called as chemical potential difference. Why? Because chemical potential which differently depend upon the concentration is going to be equal in both phases at this condition. It means chemical potential at 30% ammonia, chemical potential of ammonia in gas phase at 30% concentration, and chemical potential of ammonia in liquid phase at 20% ammonia is found to be equal. Clear beta? It means the equality of chemical potential will give the guarantee that system reach to the equilibrium. The true driving force for the mass transfer should be what? Either chemical potential difference, or you should say as a activity difference. Activity. So chemical potential is a function of composition, but they are differently depend upon the composition. It means when the chemical potential of the ammonia in the gas phase and liquid phase is going to be equal, but they are at different concentrations. Clear? At this concentration of ammonia in the gas phase and this concentration of ammonia in the liquid phase, the chemical potential of ammonia in the gas and liquid phase is going to be equal. The true driving force for the mass transfer is what? Between the phases. If you're talking about mass transfer between the more than one phases, then always we should bother about the driving force as a chemical potential difference. At the same time, in multiple phase system, we customarily deal with the diffusional process in each phase separately. What is customary? Customary means it's a tradition, customs. So it is tradition. If you're talking about the mass transfer between multiple phases, between gas phase to liquid phase, then we are not talking about the mass transfer as a whole system. We are talking about mass transfer in individual gas phase and individual liquid phase. And in individual gas phase, the driving force is what? Concentration difference. Is this clear? So if you're talking about the mass transfer in multiple phases, then it is customary to define the rate of mass transfer in individual phases, and in individual phases we can write the driving force as a chemical difference or concentration difference because it is easy to visualize. Are you getting a point? So today I told you very different types of mass transfer. Now as far as driving force is concerned, now driving force, so through this example we can define कि in this case driving force for the mass transfer, please. Driving force for mass transfer. So through this example, when you are going to allow the multiple phases be in contact, if the two-phase system, not at equilibrium, as shown in the figure, is allowed in contact spontaneous alteration through molecular diffusion occurs. And ultimately bringing the system to state of equilibrium. Initially they were not at equilibrium, but at finally they will reach to the state of equilibrium, and alteration stop. Alteration stops. Whatever change is there, that change will not further possible. So you should write here water, it's air plus ammonia at the given set temperature and pressure is being contact with the water, then transport is here due to random motion of molecules, and this transport will continue till system reach to the equilibrium. Once the equilibrium is established, then y and x, this y and this x is the equilibrium composition. Clear? So at the end of operation, concentration of ammonia in gas phase is uniform and also uniform in liquid phase. But at different values. Means y is not equal to x. But chemical potential, the chemical potential of the ammonia which is differently depend upon depend on concentration in two phases will be uniform. Everywhere throughout the system. Means what is uniform? That is uniform in liquid phase, that is uniform in gas phase, but at different values. But the chemical potential will be uniform throughout the system. It means mu of ammonia in gas phase is equal to mu of ammonia in liquid phase is going to be equal. Clear beta? At a given temperature and pressure. So uniformity of this will brought the system to the equilibrium. Yes or no? Hence uniformity of chemical potential among phases brought system to be to equilibrium. Hence, hence the hence the true driving force for diffusion is for mass transfer is chemical potential difference. Clear, beta? But I told you in multiple phases we customarily deal with the diffusion process in each phase separately, and within one phase it is usually described in terms of that which is most readily observed, namely concentration difference. Clear? But as a whole system, driving force is what? In individual phases, so you should write. In individual phase, driving force is considerable. But in multiple phases, because it is very easy to observe the chemical potential, concentration difference. Huh? So in whole system, driving force is chemical potential difference. But in individual phases, always it is better to write the difference in concentration and driving force. Okay, because in multiple phases for the mass transfer among multiple phases, it is always customary to write the rate of mass transfer in individual phases. If you're talking about rate of mass transfer in individual phases, then we should write the driving force as a concentration difference. Clear? Any problem till now? So there is a 15-minute break. Then we'll start the class for next 1 hour. है ना? Just go and take the break fast. अभी तक कुछ समझ में आया? What is the mass transfer? What is driving force and all? सर थर्मो में आएगा. Okay, am I audible to you? Now I am going to discuss here molecular mass transfer. This was this was the introduction chapter. Now I told you two types of mass transfer is there. One is called molecular mass transfer. Second is called convective mass transfer. So we are going to start the chapter which is called as second chapter, molecular and in molecular mass transfer what is mechanism is molecular diffusion. Clear? So what I told you we have already noticed that if a solution is everywhere uniform in concentration of its constituent, no alteration occur. But as long as it is non-uniform, then what happen? As long as it is not uniform, it means there is a difference in concentration is there. The solution is spontaneously brought to the uniformity by diffusion. Yes or no? Clear? If you have a solution is there, I told you one example, just like you can take, and this you can do from your own. You can take salt solution, in a glass of water, in a glass, half salt means just you can add some water in the some salt in the water, and over this, in the part of what glass you can place the pure water. Then what happen? Ki as there is a non-uniformity is there in that, then there is a molecular diffusion will take place, and this ultimately make the concentration uniform throughout. After a long time, it becomes uniform concentration throughout. That is only by the molecular diffusion. Yes or no? When you have not placed any mechanical stirrer or any spoon. If you're using a spoon, then it's called as convective mass transfer. So if we are uh, placing the water over it and hold for sufficient time without any disturbance, then after a long time the solution becomes uniform throughout, and that is only by molecular diffusion. That I already told you, है ना? And the rate at which, listen, the rate at which the solute moves at any point in any direction must therefore depend on concentration gradient at that point and in that direction. Clear? So what I'm talking about, the rate of transport, the rate at which the rate at which a solute moves at any point in any direction depends on the concentration gradient at that point in that direction. Clear? In direction, suppose I'm talking about if the solute get transferred from this point in this direction, then the rate of transport will depend upon what is the concentration gradient at that point in this direction. Means we can say the rate we can define as, how can define the rate of mass transfer? The rate of diffusion can be defined as So what is rate actually? Rate is the amount of solute that get transported, in unit time in through unit area normal to the direction of transport. That's called as rate. Clear, beta? Clear है? Now listen. So we can define the rate in terms of molar flux. So rate can be defined better in terms of molar flux. What is molar flux? Mole, or you can say amount of, or you can say flux. What is flux is here? The flux is nothing. It's a amount of species that get transported through unit area in unit time, or amount of species that get transported in unit time through unit area normal to direction of transport is defined as amount of species get transported, defined as the amount of species that get transported per unit time through unit area normal to direction of transport. Means area should be what? Normal to direction of transport. This is what the flux. So amounts we can define in terms of mole or mass. That's why the two types of flux is there, depending upon how we are going to represent the amount. So there may be either molar flux, or mass flux. And you know what is the relationship between the rate and flux? I'll do in the heat transfer. Flux is nothing, it's rate upon area. So flux you can also define as the rate of transport is defined as rate, because amount per unit time is called rate. The rate of transport of species through unit area normal to direction of transport is also called as flux. Clear, beta? Any problem? So depending upon the amount, depending upon how the amount we are going to represent in terms of mole or mass, we have two types of flux: molar flux and mass flux. Any problem? Now listen carefully. So area should be always being measured in direction normal to the transport or normal to diffusion. Is this clear? If a non-uniform solution is there, if non-uniform solution even containing only two constituents, if you have a non-uniform solution and even they are containing only two constituents, both the constituents must diffuse if uniformity is the ultimate result. Yes or no? In order to become a non-uniform solution is there and that consists two species, then obviously they will diffuse from one. Both the components will get diffuses in order to make the solution what uniform. Yes or no? And this leads to the use of two fluxes to decide the motion of one constituents. This leads to the use of two types of fluxes is there to describe the motion of one constituent. Means we can define the motion of any one of the species, any one of the constituents by the two types of flux. One is called as N, other is called as J. Clear? Now in order to next is in order to describe motion of any constituent species, any constituent species or any component you can say in solution by following two fluxes. One is Ni and second is Ji. I for any species, any constituent species I in solution. So we can describe the motion of any constituent species in solution by the two fluxes. One is Ni and Ji. What is Ni? Ni is a flux of species I with respect to a fixed location in a space. It is a flux of species I with respect to flux of species I with respect to fixed location in a space. Clear? While Ji is the flux of a species with respect to average molar velocity of all constituents. Flux of species I with respect to average velocity of all species. All species. Clear? The two types of flux we have seen here. What is the difference in these two? Ni is basically the flux of species I with respect to fixed location in space, means with respect to stationary observer. Also you can say it's a flux of species I with respect to fixed location, or you can say with respect to stationary observer. And this is a flux of species I with respect to an observer moving with some average velocity. Moving with some average velocity. Clear beta? So for the same species we can find the two types of fluxes there. two way is there to measure the motion of the species. One is with respect to some fixed coordinate, other is with respect to some moving coordinate. And this you can easily understood by, listen, if a person has put perfume on his body, listen carefully, if a person simply puts perfume on his body, and when he and observer both are either stationary, suppose just you can imagine, if a person has put perfume on his body and he and observer both are either stationary or moving with the same velocity, in that case, the flux of perfume molecules, with reference to observer is due to only concentration difference or only due to molecular diffusion. Is this clear? Are you getting point? Means, for example, if a person put perfume on his body and he and observer either both are stationary or both are moving with the same velocity, either both are stationary or both are moving with the same velocity, then the flux of perfume molecules with reference to observer, flux of reference molecule with respect to observer is due to only difference in concentration. Means he will able to smell the observer. Suppose you put perfume on his shirt, on your shirt, and you and your friend is moving with the same speed, then whatever the smell is what? Smell in the sense of diffusion or transport of the perfume molecules. So transport of the perfume molecule is only because of difference in concentration, because from the region of high concentration to low concentration, that is called as molecular diffusion or mass transfer. Is this clear? But if person is moving and observer is stationary, then tell me, if person is moving and observer is stationary, in that case what happened? If person is moving and observer is stationary, then transport of molecule is observed is because of both effects, combined effect. What combined effect is there? Means in that case, transport of the perfume molecule is due to combined effect, and combined effect because of person is also moving, you are also moving. So any species, any smell that is getting by, that get smell by the observer who is stationary, is because of two effect, combined effect. One is because of difference in concentration, as well as because of motion of the person. Is this clear? Who put the perfume on itself, on the body? Clear है? It is very similar. For example, if suppose you are sitting in a train, and train is moving with some speed, and there is another train in parallel to, in other track parallel to this, is also moving with the same speed, है ना? And suppose one child is running in a train, One child is running in train with 1 meter per second. Then any transport of that person, because boys are running, so any transport, boys are just like perfume molecules. So any boys that is running with the velocity of 1 meter per second, that is only by its own contribution, yes or no? Let's say the boat train are either stationary or boat train is moving with the same speed in same direction. Either boat train or stationary or boat train is moving with the same speed. And in one train, one guys, children are moving with the same speed. So suppose you are sitting in other train where no childs were there. You are an observer. So for you, an observer, it seems that children are moving with only velocity of 1 meter per second. Yes or no? Because you are also moving with the reference frame. You are also moving with some reference frame. You are also moving with the same reference frame as the same reference frame as in the reference frame particle is moving or childs are moving. You clear? Yes or no? But at the same time, suppose as an observer you are sitting on a platform and train is moving with some velocity. Clear, beta? And one child is moving in the train with 1 meter per second and train is moving with, let's say, 45 meter per second of velocity. Train is, just you can imagine, train is moving with the 45 meter per second and a child in a train is moving with 1 meter per second, and you an observer, previously you were in another train which is moving with the same speed. Now you are on a platform, you are a stationary observer. Now same child is moving. Then for you, the any transport of that child is because of two contribution. One is any child that is going to transport in within train is by two contribution. One is its own contribution, that is called as diffusive transport, and other is due to bulk transport. Bulk means the system is moving. Is this clear? Because train is also moving. Then along with the movement of the train also, yes or no? Tell me please. The two contribution is there, na? So I am talking about bulk flow of what? I'm here in this case I'm talking about bulk flow of molecules, not bulk flow of medium. In the heat transfer we have talked about the bulk flow of medium. Here I'm talking about bulk flow of what? Bulk flow of particles. Is this clear? So the child is a species. Child was a species, and its transport of that child we can measure in two different reference frame, with respect to two different reference frame. One reference frame, one transport of child we are going to measure with respect to stationary reference frame, and the other we are going to measure with respect to moving reference frame with some average velocity. So with respect to stationary reference frame, we are getting the any transport of that child is because of two contribution. One is called as bulk contribution, other is called as diffusive flux contribution. While when the observer is moving with some average velocity, observer is also moving some average velocity, then he observe Only one contribution. Any transport is just because of only one its own contribution. Yes or no? Clear, beta? वो क्लियर है नहीं? You can also understand through one more example. Suppose you are if you have ever go, obviously when you will go in a mall, then there is a accelerator is there. If let's say two parallel accelerator is there, or suppose you an observer and your friend is there, or let's say I'm talking about you and a child is there. You and a child both are on the same accelerator. Clear? And accelerator is moving with some speed, and if child is want to reach faster, then what happen? The child start moving on that accelerator to reach early on the top or early on the bottom. You and child both are on the accelerator. So any movement of the child for you is just because of for any movement of child, any transport of that child is because of its own contribution only for you, because you are also on the same reference frame as the child was. And in the second case, you are aside. You are not on the accelerator. You are a stationary observer. You are below or top of the accelerator. You are stationary. Now the child is moving on accelerator. Then any transport of that child is because of two contribution. One its own contribution and other what accelerator does. Yes or no? So what accelerator does, that is called as bulk contribution, and what the child does is called as diffusive flux contribution. That's because of the concentration difference. Is this clear? Yes or no? So what I want to say here, in order to describe the motion of any constituent of a species in solution, we can have two types of flux. For any one species, we have two types of flux. Miss, it's all depend upon reference frame. So as far as species is concerned, if I'm talking about, let's say I just put a perfume on our body, and I am a carrier of perfume molecules. I'm acting as a carrier of perfume molecules, and other friend is my observer. Other friend is getting observer. If observer and carrier as a me is either both are stationary or both are moving with the same velocity, in that case any transport of the perfume molecules is just because of diffusive flux or difference in concentration. But if me as a carrier is moving but observer, the friend or my friend is stationary, then any transport of the perfume molecules he is going to be felt is because of two contribution. One is bulk contribution, means because carrier is also moving, and also because of difference in concentration. Is this clear? Now it's very clear. I I have given you many example. Now tell me, if a person is moving with perfume put on a body, another person is stationary with perfume put on his body. Clear? If a person is moving by putting the perfume on his body, and other person is stationary by putting the perfume on the same body, on his body, the difference in these two corresponds to what? So if in both cases the perfume get transported, in one case the person is moving, and in other case person is stationary. So for an stationary observer, what difference the as a stationary observer you will feel? Difference in these two cases. In one case, the person is moving with the velocity by putting the perfume on his body, and in other case, the person is stationary by putting the perfume on his body. Then for an another person which is stationary, for him what difference he will felt, and why this difference is there? That difference corresponds to what? Anyone? The difference between the two types of flux is there, and the difference in two types of flux corresponds to what? Anyone? Yes, very good, excellent. Flux due to bulk contribution, bulk flow. Bulk means perfume molecules and also the carrier. Clear hai, yes or no? What about other people? Not getting? And another example has been very nice example has been taken by the Trebol. I would like to share with you. A fisherman is most interested in the rate at which the fish swims up. I would like to share that example that is given by Trebol. Just wait for a moment. My more motive is you should be clear about this. Now listen. A beautiful example is given by the Trebol. Imagine a fisherman is fishing in a river. Imagine, just you can imagine. Imagine a fisherman is fishing in the river with baited hook. Means जानते हो ना फंसाने के लिए. With baited hook. So fisherman is most interested in the rate at which the fish swims upstream against the flowing current to reach his baited hook. Because fisherman is waiting at fixed location. The fisherman is observer and he is stationary. So for an observer, he is more interested in the rate at which the fish swims upstream against the flowing current to reach his baited hook. Yes or no? And baited hook is fixed location. Baited hook is a fixed location, and as a fisherman, he is more interested in what? The rate at which fish swims upstream against the flowing current. And that is analogous to what? Na. Why Na? Because the fish comes to the flux of fish. What is flux? Amount of fish that comes through unit area, unit time. That is flux. The flux of fish comes For an flux of this phase, in this case, for an observer who is stationary, is because of two contribution. One is what? One is due to its own contribution, and other is due to what? And other is due to bulk contribution of river. River is also moving with some speed. Yes or no? And in second case, let's say the fisherman is on the boat and moving with the same velocity as of the river. Fisherman fisherman is now with their baited hook is on the boat, and the boat is moving with the same speed as of the river. Then any flux of fish is corresponds to what? Yeah, it's diffusion only. Clear? It's so which flux will indicate you which flux is a measure of characteristic feature of individual species, or you can say in which types of flux if you want to measure. I told you two types of fluxes is there, Ni and Ji. Then in which types of flux you are if you want to measure the characteristic feature of the fish, then through which flux you can measure? Through which flux you can measure the characteristic feature of the fish or ability of the fish to swim? If you want to measure the ability of the fish to swim, through which flux you can measure? The Yes, excellent. With GI only, because when the fisherman is on the boat and moving with the same velocity as of the river, then he is able to know what is the ability of fish to swim. But when the fisherman is standing on the side of bank of the river by baited hook, then he is not able to measure the characteristic feature. He is able to measure the gross feature, and its combined effect is because of river is also moving and the fish is also going to swim. That's combined effect, means bulk contribution as well as diffusive contribution. Is this clear? So if you want to measure the ability of fish to swim, or you can say in short, you can say if you want to measure the characteristic feature of the species, then which flux is important? Ji. But if you want to measure, if you want to design how much time it will take to reach the fish on a baited hook, then obviously Ni is important. Yes or no? In design of equipment, which flux is important? Ni is important. Clear? I think it is very clear. Now please write. Wait. Also I would like to, at the last, let's say this is what reference plane is there. This is what I want to, this is what molecular flux for stationary object. For stationary object, stationary observer, the molecular flux for stationary observer, the molecular flux is what, J? So when observer is velocity is 0, then it's simple. Now better is that before this I would like to write, please, Ji is nothing, Ci flux is nothing, concentration into velocity. So Ci into Vi minus V star. V star is nothing, it's the molar average velocity. It's molar average velocity. Because I told you, Gi is the flux of species with respect to average velocity of all species. Average velocity of all species. Means when observer is moving with average velocity, when the fisherman is moving with some velocity, then we can measure only the diffusive flux, and that's called as diffusive flux or beta. बस 5 मिनट बेटा 5 मिनट. It's diffusive flux. बस 5-10 मिनट. अरे यार. Clear? Ni equal to Ci into Vi, and this is called as total. जाओ 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 मामा जाओ total molar flux, and which is sum of diffusive flux, because this is the flux with respect to stationary observer. So that is because of diffusive flux plus what? Bulk flux. Clear? Or convective flux you can say also. Or better that you can write better advective flux. Means bulk motion of what? Molecules. Clear? This is the Ni and Ji. This is called diffusive flux, and V star is called as molar average velocity. V star is defined here. So this Gi is called diffusive flux only. Ni is some diffusive flux plus bulk flow flux. When molar average velocity is 0, when molar average velocity is 0 means when the observer is stationary, in that case when observer is stationary, in that case the diffusive flux is there only. So please listen. If you open this, what is V star? How can find V star is how can find it's the average velocity of all species. Average velocity of all species in mixture. How can I find this? I will discuss it. हाँ बस वेट वेट बेटा वेट चल रहा है. हाँ अच्छा रुकिए चल रहा है. तो इफ़ यू ओपन दिस माय स्टूडेंट, जे आई इक्वल टू सी आई इंटू वी आई माइनस सी आई इंटू वी स्टार. जे आई सी आई इंटू वी आई इज नथिंग, इट्स कॉल्ड एज व्हाट, एन आई minus ci into v star. Is this clear? Where vi is the velocity of 10 मिनट ले जाओ. तो listen, what is vi? Vi is the species velocity of species I. So and I is the species for which we are going to measure the characteristic feature. So if you want to measure the specific characteristic feature of the fish, then I is the fish. Clear? How can find the V star? V star is the average velocity of all species in the mixture. How can find the average velocity? Listen, what why C is what concern, and you can see the product of concentration into velocity will give you the molar flux. You can see concentration is mole per meter cube and velocity is meter per second. If you multiply this become mole per meter square per second. Yes or no? So that's why the product of concentration and velocity will give you the molar flux of that species. And V star is the molar average velocity, and that is simply called as, I can measure where V star I can find as a, how can find the, let's say in a mixture the number of A, B, C, 3 species are there or n species are there. For every species there number of molecules are there. Yes or no? Here concentration of this Ca, here it's Cb, here it's Cc. Yes or no? Let's say in a mixture there 3 species are there, A, B and C. And if you want to measure average velocity, and every molecules are moving with some velocity here, Va, Vb, Vc. Va, Vb, Vc are the velocity of A and B. Va, here Vb and here Vc. Va, Vb, Vc are the velocities. Then if you want to find out the average velocity, then we should write the mass balance. Because the total mass, let's say total concentration is here C, and let's say average velocity mixture is what, C V star. Then C is total concentration into average velocity, that is the total mass of system, and that should be equal to what, or you can say total mass flux of system, and this should be sum of individual mass of the species. It means it's Ca into Va plus Cb into Vb plus Cc into Vc. Then you can find the V star as summation of Ci into Vi upon C. Yes or no? C is the total concentration. That is what I told you. Then V star I can find as summation of Ci into Vi upon C. And C is nothing, is summation of where I equal to 1 to n. I equal to 1 to n. N is the number of species present in the mixture. Is this clear? So here reference frame, moving reference frame is what? moving with average, and this is the average velocity of all species. Just like you can imagine, in the perfume case, the V star is the average velocity of all perfume and the carrier. Clear, beta? So this is what the flux with respect to stationary observer. Now, then please, this is the main equation. When I open this, Ji is found to be Ni minus Ci into V star is nothing, is summation of Ci into Vi upon summation of Ci, and Ci upon total concentration is nothing, it's a mole fraction. So I can find Ji is equal to Ni minus Xi into summation of Ci into Vi. Ji is equal to Ni minus Xi. Ci into Vi from this equation is nothing, it's Ni. So it's summation of Ni. So ultimately you can write this equation as a Ni is the total molar flux. Why total? Because it's a contribution. Total molar flux is what contribution of two flux, diffusive plus bulk flow. So this you can see here, it's Ji plus Xi into summation of Ni. That's what is the final result. This is what is called as diffusive flux contribution or molecular flux contribution, diffusive flux contribution, and this is bulk flow contribution. Is this clear? Yes or no? Clear hai? So that's all. We'll continue by tomorrow.